Hi guys, welcome back to disinfection and sterilization. Today we'll cover some key sterilization methods used in healthcare, focusing on how and when each is applied. Then we'll dive into steam sterilization, why it's the most common method, how it works, and what parameters ensure its effectiveness. We'll also look at the main components of a steam sterilizer so you understand both its function and the importance of proper maintenance. Let's start with an overview of sterilization methods. All right, so the purpose of sterilization. The main purpose of sterilization is to destroy all microorganisms, including tough ones like spores, to prevent infections and contamination. Sterilization works by damaging key parts of the microorganism, like its cell wall, membrane, or the inside of the cell, so it can't survive or multiply. Different methods cause different types of damage. So, for example, heat can break down proteins, while chemicals might damage the cell's DNA. In the end, sterilization makes sure no microbes are left alive to cause harm. So, how does sterilization work? Sterilization kills microorganisms by damaging important parts of the cell. If the cytoplasm is damaged, the microorganism can't function or reproduce. Damaging the cell membrane or wall causes the cell to leak and die because it loses protection. Heat is a common way to do this. It destroys microorganisms by denaturing their proteins. Since proteins control all cell functions, once they're damaged, the microorganism can't survive. Before sterilization, every medical device must be properly cleaned and decontaminated. This step is critical because any leftover dirt, blood, or organic material can protect microorganisms from the sterilization process, making it less effective. And that's why we have to talk about the importance of pre-sterilization cleaning or just pre-cleaning. So processes like pre-cleaning, manual scrubbing, soaking, and rinsing are used to remove visible debris and lower the number of microorganisms. So think of it this way, sterilization can't work if microorganisms are hidden under layers of dried blood or tissue. By thoroughly cleaning first, we give sterilization direct contact with all surfaces, making sure it works as intended. Okay, so some sterilization methods vary based on device type and heat or moisture tolerance. So we have thermal energy. An example includes moist heat and dry heat. Moist heat or steam autoclaving uses pressurized steam to kill microbes quickly, while dry heat needs higher temperatures and longer exposure times used for moisture sensitive items. And then we also have chemical energy. Examples include ETO or ethylene oxide and gas plasma. ETO sterilizes heat-sensitive devices but requires careful handling and long aeration. And what that means is after the cycle is complete, you have to completely make sure that the cycle has aired out all of the gases because they are extremely toxic to us humans. Gas plasma is a much safer alternative. It's also faster and leaves no toxic residue. So this is why aside from steam sterilization, this is actually the second most common method. And then we have ionizing radiation, which uses gamma rays or electron beams to sterilize heat-sensitive single-use items without heat damage. They're very good for penetrating sealed packaging, which is ideal for bulk sterilization of disposable. And if you recall from last semester, examples include custom packs. We talked about custom packs before. They're basically just a pack that you would pack alongside other instruments for case cards, right, for surgeries. So these custom packs include drapes, uh, other disposable instruments like electrocautery cords, all sorts of things like that. Um, so choosing a method depends on material compatibility, heat sensitivity, and available resources of that healthcare facility. All right, so there's moist heat versus dry heat. Moist heat sterilization, like autoclaving, uses steam under pressure to rapidly transfer heat to instruments. Because steam transfers heat more efficiently than dry air, it requires lower temperatures and shorter exposure times to achieve sterilization. This makes it the preferred method for most heat and moisture tolerant medical devices. Meanwhile, dry heat sterilization, such as hot air ovens, they use hot air to sterilize items. Since air is a pretty poor conductor of heat compared to steam, dry heat requires higher temperatures and longer exposure times to effectively kill microorganisms. Dry heat is mainly reserved for materials that can't withstand moisture or steam, for examples, powders, oils, or some metal instruments that might corrode when exposed to moisture. It also avoids the risk of rusting or damage that steam can cause. Understanding when to use each method depends largely on the type of item and its resistance to heat and moisture. And for that reason, a lot of hospitals choose to buy instruments that can be autoclaved, right? That could withstand steam sterilization. And we're going to get more into why water activity affects the effectiveness of sterilization. So, water activity refers to the amount of free water available inside a microorganism, which plays a key role in how well certain sterilization methods work. Microorganisms with higher water content have higher water activity, meaning more free water are within their cells. This means they're generally easier to kill because water facilitates heat transfer and chemical reactions that damage vital cell components. For example, in steam sterilization, the presence of moisture enhances the coagulation of proteins and disrupts cell membranes more effectively than dry conditions. On the other hand, microorganisms with low water activity, such as spores, or those in drier states are more resistant because less water means less efficient heat conduction and fewer chemical reactions. So this is why sterilization methods that rely on moisture like steam tend to be faster and more effective than dry heat. Understanding water activity helps us select the most appropriate sterilization method and conditions for different types of microorganisms and materials. So the key requirements of sterilization, we have time, temperature, and the sterilant used. So successful sterilization requires careful control of these three factors. So for time, enough exposure time is needed for the sterilant to fully kill all microorganisms. And then for the temperature, each method has a required temperature range like 121 to 134 degrees Celsius for steam to effectively destroy microbes. And for the sterilant, it's obviously the agent used. That could be heat, chemical, or radiation. It must be appropriate for the device and effective against the microbes. So all of these three must work together. If one is off, sterilization can fail. For example, lower temperatures need longer times, and some materials can only tolerate certain sterilants. Monitoring these ensures reliable sterilization every single time. So now we're going to look at the choice of sterilization method. When choosing sterilization methods, the device's material and design are key. So plastics, rubber, and delicate electronics often can't tolerate the heat and moisture of steam sterilization. For these reasons, low temperature methods like ETO or more specifically gas plasma are better for avoiding damage and corrosion to these items. Delicate instruments need methods that preserve their shape and function without causing harm. Using the wrong method can damage devices. For example, moist heat can corrode certain metals, dry heat can warp plastics, some metals can leave residues or degrade materials faster. So selecting the right method protects both the device and the patient's safety. So the availability of methods in the MDRD. In the MDRD, sterilization choices are limited by, what equipment and resources are available in the healthcare facility. Steam autoclaves are common because they're very efficient and easy to use. Uh, More advanced methods like ethylene oxide may not be available due to cost, complexity, and special training requirements. As you remember, sorry, last class, I mentioned that you have to be in full PPE when working with ETO, and everyone has to constantly rotate if they've been exposed a certain amount of time. So it really does cause the the healthcare facility a lot of resources. So for that reason, facilities must balance device needs with what equipment and expertise they have. Sometimes the ideal method isn't practical, so validated alternatives are used instead. Sorry, I am getting a call. All right, so compatibility in sterilization. In sterilization, compatibility means that the medical device and the sterilization method work well together without causing damage to the device or compromising sterilization effectiveness. So, this involves two key considerations. First, the device must be able to withstand the physical and chemical conditions of the sterilization process. For example, materials like plastics, rubber, and electronics may be sensitive to high heat, moisture, or harsh chemicals. Second, the sterilization method must be capable of effectively sterilizing the device without being hindered by the device's materials or design features, such as tight lumens or complex shapes. If the sterilization method harms the device by warping, cracking, corroding, or degrading materials, then the device's function or safety may be compromised. Therefore, selecting a compatible sterilization method ensures the device remains safe and functional while achieving complete microbial destruction. So, here are some more key considerations for compatibility. It's important that the device can handle the process without damage. Steam sterilization needs devices that can tolerate high heat and moisture. Heat and moisture sensitive materials like plastics, rubber, or electronics can be damaged by steam. Chemical sterilization needs devices that can be fully soaked and resist chemicals. Moisture sensitive parts, especially electronics, may corrode or break down with chemical exposure. Overall, the device must withstand the specific sterilization conditions, temperature, pressure, moisture, or chemicals without losing functions or integrity. So for that, we're going to talk about the role of the MIFU or Manufacturer's Instructions for Use. Uh, it is essential for selecting and applying the correct sterilization method. They specify approved sterilization parameters such as temperature, sterilant type, and exposure time to ensure effective sterilization without damaging the device. It also clarifies the device's intended use and handling, influencing how it should be sterilized, developed through usability engineering. The instructions are designed to be clear and user friendly. Incorporating risk management, the MIFU identifies potential hazards and outlines steps to reduce risks to both users and devices. It ensures compliance with industry standards, regulatory requirements, and safety expectations. Additionally, the MIFU confirms that the device will perform safely after sterilization and includes legal and technical details specific to the product. That's why it's important to always consult and follow the MIFU to ensure effective and compliant sterilization. So there are two categories for the most part that medical devices fall into, aside from reusable ones. So we have single-use devices or SUDs and reposable items. SUDs are designed for one-time use only and must be discarded after each use. Examples include syringes, scalpels, or surgical drapes, which we've mentioned in custom packs. Reposable items can be safely reused, but only a limited number of times. A tracking system is needed to monitor how often they're processed to ensure they're removed before exceeding safe limits. Examples include certain surgical instruments, such as the Da Vinci robotic systems. Um, so, proper management and tracking are essential to maintain safety and device integrity. So, for steam sterilization, we already know that it's the most common and effective method used in Canadian MDRDs. The CSA, or Canadian Standards Association, recommends steam sterilization whenever possible, as it provides reliable, complete sterilization using heat, moisture, and pressure. Even for semi-critical devices, those only contacting mucous membranes, the mouth, rectum, steam sterilization is still preferred over high-level disinfection so long as steam does not damage them. But for that reason alone, um, most semi-critical devices, like when you think about them, it's literally just endoscopes. And endoscopes, for the most part, especially flexible ones such as colonoscopes, bronchoscopes, gastroscopes, they're not actually compatible with steam. So for the most part, when you think about semi-critical, you don't think steam sterilization because they actually have to go through high-level disinfection due to incompatible materials. Overall, though, steam sterilization is the standard for thorough, safe sterilization. So preparing medical devices and packages for steam sterilization is essential. So you have to make sure that the steam reaches all parts of the device to ensure complete sterilization, even through packaging, such as the disposable wrappers and pill pouches. because these packaging also protects the device from contamination during handling and storage, keeping it sterile until use. If packaging blocks steam or is not sealed properly, sterilization can fail. So if it's wrapped too tightly, there's no way for sterilants to go through them, especially in the wrapper techniques. There's no way for sterilants to go through them. So you actually have to make sure it's not wrapped too tightly. And for that reason, you have to make sure it's not wrapped too loosely either, because if it's wrapped too loosely, you're more likely to unravel the package if you were to touch it. So preparation of reusable medical devices for sterilization. So proper preparation is essential for effective sterilization. So first step is to remove all soil and residue, as contamination blocks steam and reduces its effectiveness. Then you have to disassemble devices per the manufacturer's instructions to expose all surfaces. So for some instruments, you have to disassemble it, but then because it's a complex part or it's a really small part that could easily get lost, you either have to assemble it again after cleaning it properly in its disassembled state, or you have to place it in these mesh baskets that keep it safe and together so that when people receive it in assembly, they're not going around in circles looking for that small piece, right? So you have to make sure that they could easily access it again so that they could assemble it after a washer disinfector cycle, for example. And of course, you have to make sure to open ratchets and valves to allow steam access. So that's keeping, let's say, instruments like Alice forceps, scissors. You have to make sure they're in open position so that the joints, the hinges are accessed by the stirlant. You have to check lumens to ensure they're clear, remove obturators or stylets to sterilize internal parts. So this is a obturator or stylet. It keeps needles clear and prevents blockages for smoother use. So for the most part, this part here is actually solid. There's nothing in it. But here is the actual needle where you have to take its proper brush size and clear it. And then you also have to take pressurized water to spray through it. And then in the assembly side, what they'll do is they'll wear gloves. The technicians will wear gloves. Take a lint-free white towel, put it at this end here. Just make sure not to plug it completely, and then blow compressed air through this gap here. And if there's nothing coming out, no brown stains or red stains, it's completely clear. That means the needle is completely cleaned. It's been cleaned properly. So you also have to avoid adding moisture inside lumens before sterilization, as it can also interfere with the process. And of course, always follow the MIFUs for device-specific prep steps. So packaging for sterilization. I know it feels like we're just beating a dead horse constantly here, but this is because I want to put emphasis in the importance of packaging. So if pre-cleaning is the most important steps before decontamination, for example, you would say packaging is the most important step in assembly. So when preparing medical devices for sterilization, proper packaging is absolutely essential, not just for cleanliness sake, but for safety and compliance. Each medical device must be packaged according to specific standards that ensure two main things. First, that sterilization is effective, and second, that the device remains sterile until use. The material used for the packaging must allow the sterilant, such as steam or gas, to fully penetrate the packaging. This ensures that the sterilizing agent reaches every surface of the device inside. Equally important, after sterilization, the packaging must allow for the sterilant to be effectively removed. This prevents any residue from remaining and ensures that contents are safe and ready for use. And then for post-sterilization protection, after sterilization, maintaining sterility is just as important as the process itself. Packaging plays a critical role in protecting the device from contamination from the moment it leaves the sterilizer to storage and then until it is used. The packaging must be strong and durable enough to withstand constant handling, transport, and storage without tearing or compromising the sterile barrier. At the same time, it should allow easy and safe removal of the device when needed without introducing contamination. So if you were to look at this picture here, how scrub nurses access the instruments inside is we actually make it so it's easier for them to just simply, pull apart one part of the tape here. So they would pull this up and just open it like an envelope. That's how it works. If we make it too challenging, too tight, if we use too much tape, it's going to burden the nurse. And they will probably call MDRD to complain about that because the more complicated your wrapping, the more tape you use, the more likely you're going to compromise their sterile field, right? The more likely they're going to make an error. That's why we have to make sure it's a very simple step. They just have to open one part and that's easy. That's it. So like it said, packaging is a vital step to ensure sterilized devices remain sterile until use. One common method is wrapping devices using accepted techniques like envelope or square wrapping. So this right here is called square wrapping and it's the most used method in hospitals because it's very simple as you can see here. It also uses the least amount of tape, I believe, because if you were to look here, this method, all those tape used, it's very unnecessary. And the nurses, obviously, it's more work for them to have to remove this part, then this part here, and then unravel this part, and then open it. For this one, they just have to rip the tape, pull this tongue here, and then just unravel it very quickly. Another method are sterilization pouches, as you see here. They're widely used more for backup instruments, single instruments, it's important to follow the pouches manufacturer instructions to ensure they maintain an effective sterile barrier and allow proper steam penetration. So this example I've shown here is actually not self-sealing. So what that means is some sterilization pouches, they come in as a specific size already. So let's say a pouch comes in 12 inches and 11 inches, right, in length. Those ones, it's already closed on one side. It's already sealed on one side, and it just comes with an adhesive that you could, fold inward to seal it, and then you could place it in the sterilizer. This one comes in a roll, so that means, it's always open. So what you do is you would cut it according to the size of the instrument, seal one half, put all the instruments you need in there, along with the indicator, and then seal one end. And that's how you would then sterilize it, right? And then for devices needing extra protection or specific sterilization conditions, rigid containers or container systems are used. These containers protect delicate instruments during handling and transport and maintain sterility effectively. So these kinds of containers actually are more used for instrument sets. So what I mean by that is it's used for specific procedures. So if we were to use an example such as labor and delivery, for example, um, labor and delivery, as all of you should know, is considered an emergency procedure because women cannot choose when they'll give birth. It kind of just happens whenever the baby wants to come out. So what happens is we have a bunch of sets in here for L&D, just so that it's easier for the nurses or doctor to access it without having to open several sets, right? So everything they need to deliver a baby safely would be in the set. And on that note too, sterilization pouches, like I said, they're more for backups. So let's say an OR received an instrument tray like this. They open it up, they notice on the label it says, oh, missing an Alice forceps. And for some procedures, an Alice forceps might not be pertinent to it, right? They might say, oh, it's okay if it's missing Alice forceps. But if they were to receive it and they needed the Alice forceps for some reason, they could just call and say, hey, I need a pill pouch version. So this pill pouch version of Alice forceps. And they could just specify what size they want, how many they want, and we will send them the pill pouch versions of those items. And a lot of hospitals, if not all, actually follow this system. We keep a lot of backups and individual instruments in pill pouches. All right, so now factors affecting sterilant penetration. Like I said, packaging is a vital step to ensure sterilized devices remain sterile until use. Wrapping devices is a very common method. Only accepted techniques like envelope or square wrapping must be used, depending on your healthcare facility's procedures and standards. They're designed to allow steam penetration while protecting the device from contamination. And like I said, sterilization pouches are another widely used options. Each packaging method must be chosen based on the device type, sterilization method, and handling requirements to ensure patient safety. So there are also more considerations for packaging. The wrapper type is critical. The material used must allow the sterilant, often steam, to fully penetrate and reach the device inside. At the same time, it must act as an effective barrier to protect the device from contamination after sterilization. And of course, there's also package size and density, which affects sterilization efficacy. Larger or densely packed items may slow the penetration of sterilants, so it might require longer cycle times or even a different sterilization method entirely. So an example that would come to mind is our implant trays. Implant trays, as you can imagine, can contain hundreds of screw types, screw sizes. Um, we also have metal plates that they would use if someone were to break, a bone in their leg. They have to determine which metal plate to use during surgery. It's not really something that you could just decide before surgery. So that's why implant trays tend to have a large number of plates, screws, all of these instruments come in it to the point where it would have multiple levels in a tray alone. So if we were to look at here, this would be considered one level. Implant trays sometimes could go up to four levels. So it's like four of these stacked together into a massive rigid container. So if you could just imagine, that means the sterilant would slow down, right? It it doesn't really access something like that properly. So what we do is we make the cycle longer, and that's one of the reasons why implant cycles are so long. So some of these cycles actually reach up to an hour or more for that reason. All right, and then this is probably the most important part of the lecture, and that is the placement of items on the loading carriage, or also called a manifold. So proper placement of items on the loading carriage is crucial for effective sterilization. So you have to start by placing the heaviest items at the bottom. So that would be rigid containers. This positioning prevents them from crushing lighter, more delicate items. It ensures they don't block the flow of steam or sterilants to other parts of the load. So obviously you would not put um, a rigid container at the top. And we also have to think about it in an ergonomic matter. You, it's especially for a smaller person, it's going to be a challenge to lift a 25-pound tray all the way here. And it's very dangerous to you as a technician. So the safest method would just to put heavy items on the bottom. Lighter items should be placed on top, as I mentioned, so that steam could freely circulate around all items, promoting even sterilization. Arranging the load thoughtfully helps maintain sterilant access to every surface, avoiding cold spots or areas where microbes could survive. So cold spots could also be, let's say, stacking too many items together, right? There could be places where there's just a compact amount of instruments, the steam can't really penetrate it. So as you can see here, we spaced out all the rigid containers properly. Maybe an inch or two away from each other. If they're too close, the steam cannot penetrate, right? It won't be able to go through. And maybe even the sterilant will get caught up in one spot. And if the sterilant is caught up in one spot, especially steam, it will create condensation. And especially if they were improperly placed, that condensation, if you were to place a heavy metal on top of a wrapped instrument such as this, all that condensation trapped in it will start dripping down onto these wrapped instruments, right? And what that will do is create wet packs, which we'll talk about more in a bit. So successful sterilization and drying. It depends on several key steps performed correctly. So first, preparation is essential. Devices must be thoroughly cleaned and disinfected to remove any debris or organic material, as residues can protect microorganisms from sterilization. Disassemble devices according to the MIFUs to allow steam or sterilant access to all surfaces. Next up, we have proper packaging and loading. Use packaging materials compatible with the sterilization process and load the sterilizer carefully to ensure sterilant can reach every part of every item. And that's actually a very important part too. So for the most part, steam sterilant can actually handle all kinds of wrappers. It could use reusable wrappers such as this and disposable wrappers. But for some sterilization methods such as liquid chemical sterilization like hydrogen peroxide gas plasma, you cannot use reusable wrappers because these reusable wrappers will absorb all of that chemical sterilant. This one, they are thin enough where the chemicals could actually penetrate through and successfully sterilize instruments. Right. All right. So for that reason, during sterilization, maintaining strict control over time, temperature, and sterilant concentration to guarantee microbial destruction is important. And then, of course, after sterilization, drying must be complete to prevent moisture, which can lead to contamination or compromised sterility. Remember, moisture promotes microbial growth. Monitoring each phase helps achieve consistent, reliable sterilization outcomes and ensures patient safety. So, as you can see here, I put an important lettering here because this is one thing that you really have to remember, right? Now, sterilizer operation is a critical factor in ensuring effective sterilization and patient safety. Even with the best equipment, improper use can lead to sterilization failure. So the operator plays a vital role and must be well trained and knowledgeable. This includes understanding the sterilization parameters such as time, temperature, pressure, and the type of sterilant used, and how these interact to achieve complete microbial destruction. So during each cycle, the operator needs to closely monitor the process. After completion, reviewing the sterilizer's printout or cycle report. So this is what we call a printout. So our cycle report is essential to confirm that all parameters were met. If any deviations or errors appear, the operator must act immediately, either by repeating the cycle or troubleshooting the cause. This attention to detail helps prevent the risk of contaminated instruments reaching patients, thereby ensuring safety and compliance with standards. Um, so I know I said repeating the cycle, but let's say you, as a sterilizer, you were assigned to sterilize for the day. If you have to repeat a cycle due to failure or such, unfortunately, people in assembly will have to rewrap again. They have to dispose of all the disposable wrappers used. They have to put the reusable wrappers in the soiled linen because it's just not safe to use them anymore. They have steam or some other sterilant still in the reusable wrappers. So what you have to do is you put it in the soiled linen so that it could be laundered again for safe reuse. And of course, you would have to remove all the indicators. You have to change up all the tapes just so there's an accurate reading on the second try, on the second cycle, right? But I feel like you should not feel overwhelmed if you were to get this role one day, because for the most part, um, MD or D, they really take this position seriously. The You will not do it alone if you're entry level or you're brand new in the field. You will always have someone with you if you are assigned this role. So don't worry about it. You don't have to be an expert on, proper placement from the get-go. It really takes experience to get to know all of those. All right, so key responsibilities of the sterilizer technician. The success of sterilization relies heavily on the operator's key responsibilities at every stage. So during packaging, devices must be carefully packaged to use appropriate materials, whether wraps, pouches, or rigid containers were made to ensure sterilant can penetrate while protecting the device from contamination. So for this reason, you also have to quality check your colleagues' work. If they wrapped it too tight, for example, you have to return it to them and tell them, please rewrap that. Um, Obviously, you can't really see what's inside the instrument, so there's nothing you could do about that. You can't double check their work. You can't make sure if, the lumens were cleared. You just have to trust them on that part. So for the most part, if they were to see in the OR or any department, if they were to see that an instrument made it through the sterilization cycle and it was dirty, it has nothing to do with the sterilizer operator. That would be on the assembler's, you know, part. So for the most part, you do have to quality check their work, but only externally, right? You have to make sure they have tape. You have to make sure they have external indicators. You have to make sure they're using the tamper evident arrows for these rigid containers. And you also have to put the biological indicators, of course. And loading is completely the sterilizer technician's responsibility. And like I said, it's very critical. Items should be arranged to allow steam or other sterilants to circulate freely and reach all surfaces. Overloading or poor arrangement can block sterilant flow and leave items unsterilized. And I'm just gonna judge this sterilizer's work right now. This is not a very good way to load um, a manifold or loading carriage. There's already so many inconsistencies to it. Uh, I would say avoid having wrapped instruments like this be so close to metal because metal, it does gather condensation due to its density and material. So if the sterilant were to get trapped here, condensation would be trapped here, and then obviously this would become soaked. And then this part two, they're laying it kind of leaning towards the back here. This should be leaning forward, assuming that this was wrapped properly. So basically, a lot of these trays are wrapped in here. And if you can imagine, some trays have, the upper, they have a lip where it could trap condensation or moisture. So it's important to lay trays forward. So this one is a bit too tight, and you could see this person even has another level down in the bottom, so they could just put the rigid containers down there too. Oh, and if you see here, they stacked the containers like this. This is actually a viable option for steam sterilization, which I would have to say I would never do, but some hospitals actually allow stacking like this because if you could see the corrugated metal here with holes and such, the steam could actually penetrate through that to the bottom tray or instrument container. But with all the space, I would just say spread things out properly, right? There's really no need to overcrowd like this. This is a bit much. Of course, we have to talk about documentation too. So as the sterilizer operator, you have to have accurate record keeping for traceability and compliance. So this includes logging cycle parameters, putting batch numbers onto the items, initialing, all the records, and you have to record any irregularities if you find any. And of course, if you do, you have to also inform your supervisor. So these records are very vital during audits, inspections, or if a sterilization failure is suspected. And of course, as the operator, you must also know how to store these supplies properly. So after sterilization and proper drying, they have to be stored in a clean, dry, and controlled environment. Improper storage can lead to recontamination, negating the sterilization process. So let's say you didn't let the cycle cool down enough. You decided to pull out everything and put it away in the storage. What happens there is, they will gather condensation again and start dripping down on sterilized equipment and devices. So you really have to wait the proper time for them to completely cool down. And it's not just for, the sake of storing them properly. It's also for the sake of the operator's safety. If rigid containers are still too hot to the touch, operating or using them is going to be it's too dangerous for you. Why would you try touching it, right? Like why would you even put it away when it's still warm, when it's still too hot? So it's just better to be on the safe side and wait the proper amount of time for it to completely cool down. So more on loading, sterilizer carts. So these are some guidelines for optimal results. So air removal and steam penetration. You have to make sure to arrange packages so that air can be fully removed after the sterilization phase, and steam can penetrate all surfaces. Adequate steam exposure is critical for killing all microorganisms and ensuring complete sterilization. You also have to ensure adequate spacing to maintain. So you have to at least maintain 2 centimeters, about the thickness of your finger between packages. The spacing applies to all sizes, from large linen packs and basin sets to smaller items like peel pouches. Um, Proper spacing prevents steam blockage and promotes uniform sterilization. And then there's also layering and shelf placement. Avoid stacking packages directly on top of one another. Each layer should be on its own shelf, with shelf spacing equal to the spacing between packages on the shelves below. Overloading reduces sterilant flow and drying efficiency. So chamber contact. Wrapped items must not touch the inside of the sterilizer, right? So the inside of sterilizer, there's a chamber walls. Keep the load 3 to 4 inches away from the chamber surfaces to prevent damage to packaging and to allow steam to circulate freely. And as for peel pouches, you have to place them on their edges, side by side with plastic touching paper. If you were to place them against each other, plastic against plastic, due to the heat of the sterilizer, they will fuse together and warp together. So this positioning optimizes the penetration of sterilants and reduces condensation once again. So cupped instruments like bowls, basins, and similar cupped items like other trays should be placed on their edge and tilted forward. This prevents, water from pooling inside during the cycle, and it also improves drying effectiveness. So perforated instrument containers should be laid flat to allow sterilant to flow through all holes and sterilize internal contents fully. And as for solid bottom trays, they have to place them on their side to expose all surfaces to steam. And then mesh or perforated grid. Um, Use these grids on the bottom of small sterilizers to facilitate sterilant circulation. You have to reinstall them after cleaning. Linen and hard items. You have to make sure you're sterilizing both of these together, and you have to place the harder items on lower shelves, heavier items on the lower shelves. This prevents condensation from dripping onto linens, which can cause moisture retention and compromise sterilization. And I highly recommend that you guys watch this reprocessing steps. All right, so here we are, recognizing incorrect loading. So I will actually bring this picture up again in next week. I will have you guys, let me know what's the problem here. But I will go briefly over them right now. So like I said, rigid containers, not just because they're heavy, they should be placed on the bottom if you can help it, right? So this one would be best be placed here where the basket of peel pouches are. And then the peel pouch baskets should not be placed below anything heavier than it or anything, metallic, and even bundles like this, linen bundles. So it would be best to move all of these on top of here, all right? And even this one, we have a metal tray. Even if it is lighter than this linen bundle here, you should never place metal above any linens. So it would be best to maybe put these here in the bottom and carry this on top. So it's really important to shift things around here. But like I said, if you're entry level in the field, you will not work alone in the sterilization assignment. You will be with someone else. So you could find some comfort in that. And for the most part, we're very open-minded, we're very patient in MDRD because we know how many parameters you have to look at to watch out for as the sterilizer operator. So you won't be alone in this position and assignment. And even if you were here for a very long time in this field, you could still ask questions. We're very kind, we're very patient. We will give you all the tips you need. So really, in this field, it's all about experience. The more you experience things, the more you'll become more knowledgeable of all the operations and how to correctly follow them. All right, so key factors in steam sterilization that I've been mentioning so many times, temperature, moisture, pressure, and exposure time. So I'll go over them again because in a little bit we'll be looking at their relationships. So temperature. Heat is the main sterilizing agent. It's what kills microorganisms. And how it works is that they coagulate the microorganisms' proteins and disrupts their cell structures. And the sterilizer chamber consistently operates above 100 degrees Celsius, usually between 121 degrees Celsius and 134 degrees Celsius. And in Fahrenheit, we always have to ensure for steam autoclaves, they only reach a maximum of 275 degrees Fahrenheit. And this is to ensure effective sterilization. While higher temperature increases microbial kill rates, it might also start damaging materials if it gets too high, right? And next we have moisture. Steam or moist heat is much more effective than dry heat because moisture conducts heat better. This allows heat to penetrate microbial cells more rapidly, denaturing proteins more efficiently. Moist heat penetrates porous materials and lumens better than dry air, which is why steam sterilization is preferred for many instruments. And then we have pressure. The sterilizer chamber is designed to withstand high pressure. By increasing pressure, we raise the boiling point of water above 100 degrees Celsius. So it allows steam temperatures to reach even higher levels without turning back into water. For example, at about 15 psi above atmospheric pressure, steam can reach up to 121 degrees Celsius. This elevated pressure temperature relationship is key to rapid and effective sterilization. And now we have exposure time. So sterilization must be maintained for a set time to ensure all microorganisms, including the most resistant spores, are destroyed. The required exposure time depends on factors like load size and microbial resistance. Larger or denser loads may require longer cycles, but effective steam penetration and high temperatures help reduce necessary exposure time. Together, all of these factors, temperature, moisture, pressure, and exposure time, create an optimal environment for reliable steam sterilization. All right, so now we're going to be looking at the relationship between key factors. So we have the key factors of sterilization itself. So that's time, temperature, moisture, and pressure. And they are closely interconnected and must be carefully balanced. So when temperature decreases, sterilization requires more time to achieve the same microbial kill because lower heat means slower protein coagulation and slower cell death. And then on that note too, increasing temperature allows for shorter exposure times because higher heat kills microorganisms more quickly. And the only reason why we don't do higher temperature is it risks destroying the materials of the instrument, right? So some instruments cannot go above 275 degrees Fahrenheit, and that's why that's our, golden standard in MTRD for steam sterilizers. We cannot go over a certain temperature limit. And then, of course, we have moisture. It plays a crucial role as well. If moisture is reduced, say because the steam quality is poor or humidity is low, then either temperature must be raised or the exposure time extended to compensate. And moisture is critical for efficient heat transfer into organisms, especially if you're using steam. And then we have pressure, which also plays a critical role because higher pressure raises the boiling point of water, which increases the steam temperature. This elevated temperature enhances sterilization effectiveness. So because these factors affect each other, cycles are carefully designed to maintain the right balance. If any one factor is off, the sterilization cycle is more likely to fail, potentially allowing microbes to survive. So in summary, successful steam sterilization requires precise control and monitoring of time, temperature, moisture, and pressure. And that's why, as the sterilizer operator, it is your job to be knowledgeable in all of these parameters. What I can say is, though, it's modern sterilizers, they are able to monitor it for you. And the only thing you have to do is to confirm that everything, matches up. Machines, they could also have errors. So your job is to make sure that the machine didn't have any errors whatsoever in its parameter checking. And you have to just double check it carefully, and then you have to place your initials on the printout to confirm that the cycle did indeed pass. And then we're going to be looking at the quality of steam. It's a foundational element for effective steam sterilization. The entire process depends on a consistent supply of high quality steam that meets strict standards. So it requires steam that is free from contaminants like oil, particulates like minerals, and excessive moisture. Only clean, saturated steam at the correct temperature and pressure can actually reliably kill microorganisms and spores on medical instruments. System integrity is also important. So this means the water source, steam generators or boilers, and pipelines must be properly designed and installed and maintained regularly. Any contaminations or leaks in this system automatically degrades the steam quality and disrupt proper steam sterilization. Of course, process consistency hinges on controlled steam quality. So variations in steam purity or pressure can cause cycles to fail or become unreliable, posing serious risks to patient safety. So maintaining steam quality supports sorry, reproducibility of sterilization outcomes and compliance with regulatory standards. So poor steam quality doesn't just affect, efficacy of sterilization. It also damages sensitive instruments and even packaging materials. So, for example, excessive moisture can cause corrosion or staining, which shortens the lifespan of devices. All right, so now we're going to be looking at steam dryness fraction. So it's a key indicator of steam quality, especially important in medical device sterilization. It tells us how much of the steam is actually dry steam versus how much is wet steam containing water droplets. Essentially, the dryness fraction um, measures the ratio of dry steam to the total steam value, which includes both steam and any entrained moisture or water droplets. So this is important because the presence of moisture or wet steam can negatively impact sterilization. It reduces the steam's temperature and energy, hindering its ability to efficiently transfer heat and kill microorganisms. So the ideal steam ratio for sterilization purposes is 0.97 or 97% dry steam. So that means the steam should be at least 97% dry with no more than 3% moisture content. If you have more than that, you are more likely to have a wet pack or an instrument tray or bundle to come out wet. So unloading sterilizer carts. Oh, sorry. Oh, I skipped it. Why steam quality matters. So maintaining this high level of steam dryness ensures efficient heat transfer, optimal sterilization cycles, and protects the integrity of medical devices. In short, monitoring and maintaining an appropriate steam dryness fraction is essential for effective and reliable steam sterilization. Now we're looking at unloading sterilizer carts. So it's crucial to maintaining sterility, dryness, and integrity of medical devices after the cycle. So you have to wait for proper cooling first before opening the sterilizer fully. So for vacuum sterilizers, this means waiting about 10 minutes after cracking the door to allow pressure and temperature to normalize safely. For gravity sterilizers, the wait time is no longer is much longer, about 30 minutes, because the process relies on gravity displacement and cooling, which takes more time. So I'll get more into detail about vacuum and gravity sterilizers next week, I believe. So the cooling period is essential because packages and instruments inside are still extremely hot and under pressure. Opening too soon can cause, you know, condensation or sudden temperature changes, which leads to moisture buildup inside packages. So you have to avoid unloading before having allowed items to cool thoroughly. Unloading while still hot increases the risk of compromising integrity of the packaging. And when you do unload, minimize handling sterile items. Excess handling risks tearing or damaging packaging, which could expose sterile devices to contamination. So you have to handle packages gently and as few times as possible, always following proper aseptic techniques. All right, so now we have factors of drying time. So it's critical to maintaining sterility and preventing contamination. So there are several factors that influence how long this drying phase should take. And it always starts with the MIFU, for example. So you have to always refer to it for recommended drying times. There are device specific sometimes and based on validated testing to ensure devices remain sterile and safe to use. There's also package size and type. Obviously, larger or denser packages retain more moisture and require longer drying as a result. And of course, the material type also matters. So we have woven textiles, reusable textiles, paper plastic pouches, rigid containers, all have different drying characteristics. And of course, the load size and type matters too. So if it's an implant or a regular instrument, they all have different drying times. A fully loaded sterilizer will need more drying time compared to a smaller load because of the increased moisture content, right? And potential for steam to get trapped between items. Of course, steam quality, as mentioned, is very important. We have to use the correct dryness fraction, which we have no say in the matter, right? We don't um, customize the parameters ourselves as the sterilizers. That is above our pay grade. It is always going to be up to the healthcare facilities, MDRD supervisor, manager, and they have to talk to, the proper engineer in charge of these situations, which is typically someone from that machine's manufacturer. So a very popular supplier of sterilizers, especially steam sterilizers, would be Steris. We would always have Steris, service technicians coming in to maintain the sterilizer to check that all the pipes are working, there's nothing going on, right? And of course, the sterilizer's characteristics itself is very important. So the design, drying features like vacuum or filtered air drying, which we'll get into more next week, and maintenance condition all affect drying performance. Older machines or poorly maintained ones may not dry as efficiently. So achieving optimal steam quality. It's essential for effective sterilization and protecting medical devices. This requires attention to system setup, water treatment, and ongoing monitoring. So the steam line setup. Steam should be drawn from the top of the main steam line to avoid picking up water and debris that settle at the bottom. Steam traps remove condensation, while filters capture particulates, ensuring only clean, dry steam enters the sterilizer. Water treatment chemicals used for water softening or treatment must be approved for food contact or pharmaceutical use. This prevents introducing harmful residues that could affect instruments or patient safety. So basically, if the water treatment use chemicals, you have to ensure that it's also used for food. Because if it's safe for food, that means it is safe for medical devices too. Regular water evaluation. So at least once a year, water quality should be professionally tested to ensure it meets the manufacturer's specifications. If there's any tests that show impurities or imbalances, appropriate treatments, corrective treatments like filtration or chemical adjustments to the water treatment methods are necessary. And of course, complying with standards is very important too. And they should align with what we call CAN or CSA Z314 to 18 for water quality. And this guideline actually outlines national standards for steam and water use in sterilization processes. Next, we have ongoing monitoring, which is part of the responsibilities of the sterilizer operator. So steam and water quality isn't a set and forget process. Continuous monitoring and maintenance are vital to prevent fluctuations that could compromise sterilization processes. And for that, we also will get into emergency power and other sterilizer requirements. So in critical healthcare settings, sterilization services must remain operational even during power outages. That's why at least one sterilizer must be connected to the facility's emergency power supply. So it ensures that essential sterilization can continue so that we could keep supporting patient care and prevent surgical delays. And when it comes to running sterilization cycles, it's not a one size fits all. Staff must follow the facility's written procedures to select the correct cycles based on the device manufacturer's MIFU. This ensures that time, temperature, and other parameters are appropriate for the specific devices being processed, maintaining both effectiveness and safety. Um, as you all know, improper cycle selection can lead to failed sterilization or even damage the more delicate instruments. So it's important to follow protocols. Now we're going to be looking at sterilizer components and operations. So I think it's important for you guys to come back to this slide every now and then to see how it works. So we have what we call a jacket, and there's a baffle here, which is basically just a metal plate, and then the steam inlet. So steam inlet usually goes out from the top here and then spreads around slowly. And the door, which is typically locked during a cycle. If there's a cycle going on, you cannot open it until the pressure inside the chamber, that's what we call the chamber, goes down. And of course, we have the drain and filter baskets here and the steam traps. And we'll get more into detail about this in the next couple slides. All right, so the operating cycle. So the cycle begins when steam enters from the top while air is pushed out from the bottom front through the drain. So it enters through the top here. And then air is usually displaced or drained from here. Sterilization begins only when the chamber is full of steam and all air is removed, ensuring proper heat transfer. So once all the air is out of here, it essentially creates a vacuum, right? so that the steam is much more compact, much more condensed, and giving it higher chances of penetrating all the devices inside the chamber. So after sterilization, the steam is evacuated and the chamber is refilled with filtered air for safe unloading. So this is where the steam would also evacuate. All right, so now we're going to look at the chamber. So the chamber is a pressurized vessel where sterilization happens. It's built from heavy-duty steel to handle high temperatures and pressures. They come in various sizes. So we have a tabletop model here, and we also have a large floor unit model here. And this is what we would typically see. This is the size we would see in healthcare facilities like hospitals. And we have the door, which provides access and ensures a tight seal during cycles. They may use manual locks, so wheel or latch, or automatic motors on larger models. So it would be like a sliding door. Dual door setup, so it's for loading and unloading sides, prevents cross-contamination. So for the most part, older hospitals, they only have a one door setup. So for example, this one here, it looks like it's only a one door setup, even this one. So you would only load it in one way and unload it the same way. Some hospitals, they actually have it so that you load it from the assembly side and then you would have to unload it from the sterile storage side, right? Which improves, the prevention of cross-contamination. So the door has safety interlocking systems that prevent opening the door until pressure is safely released, like I mentioned earlier. And then the jacket, which is the outer steel layer around the chamber, so it would be this one. So usually it has a 3 to 4 inch gap filled with circulating steam too. And this prevents chamber walls. Sorry, this preheats chamber walls, preventing condensation when steam enters and ensures immediate steam availability. As you can see, it's like a 3 to 4 inch steel layer around the chamber itself. And of course, we have steam, which acts as both sterilant and heat conductor. It prevents condensation on instruments by keeping chamber walls hot, so walls of the chamber. And a steady supply ensures consistent sterilization conditions. And now we're going to look at the baffle and how it works. So the baffle, as you can see here, because steam is hotter, it rises, right? It's hot air. It rises from here. Otherwise, if the baffle is not here, the steam is just randomly being thrown about. And for the most part, the devices placed here will probably get the brunt of all of that steam, right? And it will most likely get wet. So the baffle makes it so that the steam has a more gentler entrance to the chamber walls. To the chamber itself, so that it's not just focusing on that one poor medical device that was placed here on this level. So, like I said, it's a metal plate in front of the steam inlet, which is this one. It deflects incoming steam to evenly distribute it across the load. It prevents the wet packs by avoiding direct steam blasts onto items, especially on this level. And then we have the drain or air outlet. It's usually located at the bottom front. It's the primary path for air removal at cycle starts. It's covered with a removable mesh filter to catch debris. Blockages here can cause sterilization failure because it's trapping air, right? So we have to make sure air is at least gone or displaced for the most part from the chambers so that steam can properly fill up all the pockets within. So this thing here, for a lot of hospitals, It's simple enough to clean. We just remove it, but you have to make sure you're wearing oven mitts. And then we also, use a compress gun on it to spray it out of any debris. Maybe some paper sometimes gets stuck in there. Some hospitals, they actually keep extras and they would rotate them out so that after this was used for the day, let's say at night, the night shift would have to put it through the decontamination, treat it like an instrument where you would brush it, clean it properly, put it through the washer disinfector. And, obviously you have to wait for it to completely dry because if you were to put it in there while it's still soaked, it could actually compromise the sterilization cycle. And I'll show you a picture here. Yeah, so the drain is right here, if you could see it properly. It's typically placed here at the front of any sterilizer. Yeah, this is the front, this is the door, this is the drain. Now we have a steam trap. So it's a heat sensitive valve that seals once the correct temperature is reached. It maintains internal pressure and temperature throughout exposure time. After the cycle, it releases the steam, which allows pressure to drop and for air to re-enter for proper drying. Now I think we're reaching the end of our slides today. So now we're going to talk about the advantages and disadvantages of steam sterilization. So for the most part, in terms of advantages, it's relatively fast. The cycles are shorter than many other methods, making it ideal for high demand settings where quick turnaround is essential. Non-toxic. So steam only uses water, right? So it's non-toxic. It leaves no harmful residues on instruments, making it safe for patients and staff. Unlike certain chemical sterilants like ETO or even hydrogen peroxide, um, in comparison, because it's just using water, it's much safer. It's also economical for that reason alone, right? Water and energy are the primary resources needed. So compared to other methods, again, like ETO, steam is far more cost effective for routine sterilization. So when I say routine, it's used every day. It's readily available. Most healthcare facilities already have the proper infrastructure to produce steam. So they have boilers, generators, making it convenient and accessible. Unfortunately, older healthcare facilities, while they have, the boilers, generators in their infrastructure, some of them don't have the proper water treatment infrastructure to actually release clean steam. So there is also that factor to keep in mind. And of course, effective penetration, right? Steam's moist heat efficiently transfers into lumens, porous materials, and complex instrument surfaces, ensuring, microbes are destroyed even in hard to reach areas. And of course, there's also disadvantages of steam sterilization. So it requires air removal. So air is a barrier to steam. Proper air removal through vacuum or gravity displacement is critical to allow steam to contact all surfaces. A failure will lead to a failed sterilization cycle. And for the most part, it's also unsuitable for heat and moisture sensitive items. So certain plastics, electronics, and delicate instruments can warp, melt, or be damaged by high heat and humidity, which limits the steam's application. It requires a cool down time, so post sterilization, hot items can't be handled immediately. Adequate cooling time is needed to prevent burns and avoid damaging packaging through moisture condensation. And of course, there's quality control challenges. Maintaining consistent steam quality, correct dryness, fraction, the pressure, temperature, it's vital. Fluctuations in steam supply, poor water quality, or equipment issues can compromise sterilization effectiveness. And so we've reached the conclusion of our week 2. And thank you for making the time to watch this video. I know it's a lot more difficult to really pay attention to a video, especially when you're at home and comfortable. But if you managed to get through this video, thank you so much. I really appreciate it. I hope it helped you understand the slides a bit better. I know it's one thing to give you the slides and just expect you to read through them, but it's another to have someone explain it in more detail, you know, even with pictures included, it could get very overwhelming. I'm still a fairly new instructor compared to others. This is literally just my second semester. I am still, learning. I'm still battling the nervousness of having to stand in front of you guys. But I can promise you that I'm always thinking of ways to teach you guys more effectively. I'm thinking of how to have you guys retain this knowledge more effectively. That's why I try to have some Kahoot sessions, where we answer questions together, maybe play some Jeopardy games as a group. Um, I've even subscribed to Quizlet so that you guys could have easy access to all these important information and terms, and so that you could study at your own time more conveniently on your smartphones if needed. Oh, and on that note, for the Quizlet, I actually created some of the terms already for week 2 of disinfection sterilization. The only thing is I used the AI function to create the terms. So basically what I did was I plugged in my PowerPoint into it. So some of them might not be too relevant. Some of them might be redundant and repeated. So I still have to go through them to fix it, but you're more than welcome to just read through it. If you see something repeated, just skip it. But yeah, for the most part, I would really appreciate it if you guys make use of all these study materials I've made. I really want you guys to succeed. And yeah, I'll see you guys next week. I hope you guys have a wonderful long weekend. Bye bye.